Welcome to a special edition of ChemVid. Today we're going to go over the electron configuration packet. So hopefully you've already read through it so you have an idea of what is going on, and then I can help clear up any of the misconceptions. Alright, so the first part of this assignment is basically just trying to tell you that things are organized by places that you can put them. So in this case, with the boarding house, you have the bunk people, the people who are, a boarder, and they are trying to stay in these different rooms, okay? So they can only be in these certain rooms. And if you watch, it looks like the manager always puts them in the bottom rooms first, and then they move upwards into the other rooms, okay? So for their code, the manager's code, if you look, this first number, the 1, is referring to the first level. And then the S is referring to the sunny side, the sunny rooms. Okay, so which side of the house it's on. And then the little 2 refers to 2 boarders in that room. So when you see something like this, all it's saying is it's just giving you a map of where all the boarders are and where they can be. Alright? Alright, so go ahead and jump down to page 3. It looks like what's over here on the right. Okay. Now, the thing about electrons is that they can only be in certain places at one time. So, when it comes to electrons, they can only be in certain orbitals. So, as you may recall, I told you that there are different orbitals instead of just orbits. Schrodinger showed us that. Okay? So the first thing that we're going to go over are the different types of orbitals. The first one is called an s orbital, and it makes a sphere type shape, okay, just like a circle or a ball, alright? So the first one we have is an s orbital. Then a p orbital looks like, some people call it a dumbbell, it looks like a figure 8. But it has that general shape. But there are 3 of them, so it ends up taking on the shape of a flower. Okay? So that is what a p orbital or p orbitals look like. And then we have 2 other ones. We have the d orbital and we have the f orbital. And the d orbital and the f orbitals are kind of hard to draw just because they're so kind of elaborate, alright? So we won't draw those, but they do exist, alright? This assignment focuses mainly on s and p, so that's what we'll focus on, but they do exist. So an s orbital is a sphere shape, and within that sphere shape, you can have 2 electrons, alright? And only 2 electrons. That's all that will fit in an s orbital. Whereas a p orbital, you can have an electron in every one of these petals. Okay? So that means that they can have 6 electrons. And then d can have 10, and f can have 14. Alright? So there is a limit to how many electrons you can place in each one of these orbitals. And that's what they were trying to get across on the first page when they showed you that only 2 electrons could fit in one room, or 3 bunk beds could fit in one room. So an s orbital can fit 2, and then a p orbital can fit 3. That's what they were trying to get at. Alright? So if we look over here at these different orbital diagrams, you can see that hydrogen only has 1 electron. We're just doing atoms today. Ions are a little different, but not by much. So since hydrogen only has one electron, it's going to go into the 1s orbital first. All right? And then carbon is going to go from, it has 6 electrons total. So it's going to put 2 in the 1s, 2 in the 2s, and then 2 in the 2p. Okay? So they spread out just like the bunks and the borders, okay? But in this case, it's where an electron is, and it's where an electron can travel. Alright, so if you scroll down a little farther, you're going to find 10, 11, and 12. And there's a little bit of stuff in between 10 and 11. But the principles are what I want to go over with you. So Aufbau's principle, or the principle that Aufbau kind of named, is that when you're in the ground state, okay, ground state, that's the key, you will fill in electrons from the bottommost orbital to the top first, okay? So if you look over here at carbon, carbon has 2 electrons in the s orbital, because the s orbitals can have 2 electrons. And then the second s orbital will also have 2. And then they put the extra 2 electrons in the p orbital. So let's go over here and pretend this is carbon for a moment, all right? So carbon has 6 electrons. You would never, ever, ever do this. Like put in the electrons, you know, wherever you wanted to, all right? This is incredibly unstable, and it's not the ground state, okay? So whenever you're filling in these orbital diagrams, always fill in the bottom first, then you just move up these rows. These rows are a pattern. They're always the same. You always have a 1s, then a 2s, then a 2p, then a 3s, and then a 3p, and then so on and so forth, all right? So whenever you're doing the ground state, you always fill them in from bottom to top. Alright, the next one is the Pauli exclusion principle. So if you look, when 2 electrons are in the same box, in the same orbital, or sharing the same space, they will always go in opposite directions. Why? Well, electrons have this thing where they're actually spinning around, okay? So electrons don't just sit there, they actually spin. And some spin clockwise and some spin counterclockwise. And if they were both spinning the same way, their momentum would add up and it would cause them to leave the orbital, which is not good. So what they're going to do is they're going to spin in opposite directions, and that way their momentum cancels each other out, and so they can stay in there and be stable in there. All right, so whenever you have 2 electrons in one orbital, you always, always, always have their spins going opposite ways. That's why we use arrows, is to denote that. All right, and then finally, Hund's rule. So Hund's rule applies to p and d and f orbitals, okay? If you notice, p orbitals have 3 orbitals inside the 1p area, okay? And d orbitals have 5 and f orbitals have 14, okay? Or 7, sorry, 7. So if you look, carbon all has their electrons spread out, okay? Hund's rule states that you would never, ever, ever, let's pretend this is carbon again, okay? You would never have an electron going here. Sorry, for some reason it's not drawing. There we go. All right, you would never have 2 electrons here, and then 2 electrons here, and then 2 electrons together. Why does it make sense that we would never pair up 2 electrons in a p orbital? If you said it's because they electrons are negative and so they'll repel one another, you're correct. Electrons want to be spread out as far as they possibly can. They don't want to be right next to each other. They only are together if that's where they have to be, all right? The orbits, like having 2 electrons in an orbit is fine, and it's okay. But if they have a choice, if electrons had the choice, they would spread out, okay? So never, ever, ever put 2 electrons in one box when you could spread out the love, okay? Spread out the electrons and get them in their own boxes. All right, so go ahead and jump down to number 14. 14 is saying that they asked students to draw the orbital diagram for an atom. And they want to know whether or not it's correct or not. All right? So the first thing you read in here is that it's the ground state of a nitrogen atom. All right? Okay, so looking at this, first off, can you see anything that is not correct? If you look over at C, this little guy right here is defying Hund's rule. Electrons don't like to have to share unless they are forced to. So C is incorrect. And I would say it says to enter in an explanation of if it's wrong. I would put that it's incorrect because of Hund's rule. 2 electrons can't be in the same orbit when they can spread out. All right? All right, so the next ones. Did you find this guy? According to Aufbau's principles, electrons are going to fill their first orbitals first and then move on. So for this guy, I was going to move him here, but is that right? No, it's not right. In fact, that electron should go all the way down here because the 2s orbital needs to have 2 electrons in it before I can fill up the p orbital. All right. Okay, so this one I would write incorrect, and I would simply put Aufbau's principle. Electrons have to fill up from the bottom to the top whenever we're talking about ground state. All right. And then this final one right here. There's 2 here, 2 here, and then 3 up here. And if I look at it, I see that they're all filled the way they're supposed to be. A nitrogen atom is supposed to have 7 electrons, so I count those up. And I find out that there are 7 electrons. So B is correct. Go ahead and see what you can do with number 15. Follow the same rules and put in the electrons for them. All right, jumping down to 18. In this one, they give you an orbital diagram and they ask you to write these 3 things about them. So first off, excited state. In the 1s space, I look over here and there are 2 electrons. So I write a little 2 up here. And that's the first part. The next one, I have a 2s orbital, because that's my next orbital. I always go in the same pattern. And this time it only has 1. And that's okay, because this is the excited state. So in the excited state, the electrons can jump around, remember? All right, my next orbital is the 2p orbital. So I'm going to write out 2p. And I count them up. There are 3 electrons in there. So I'm going to write a 3 right here. And my last one that has electrons in it is the 3s. And it has 1 electron in it. And there we have it. Alright, so an identity of an element can be found by its electrons. And I found out that this was nitrogen. And then the ground state is where all the electrons go back into their lower orbitals. So I just take all 7 electrons and put them into that pattern. Let me know if you need any help or email me with any questions. Thank you.